Welcome everybody to our Cisco lab. In today's lab, we're going to do a few activities about OSPF version 2 and version 3. The main purpose of this lab is basically to introduce you guys onto OSPF configuration. So we're basically going to learn how to set up OSPF version 2 and OSPF version 3. So we're going to do two packet tracer activities. The first packet tracer activity that we're going to be doing is this one here that I'm showing to you guys right now. It's a configuring OSPF version 2 in a single area. It's packet tracer number 8.2.2.7. After we complete this one, we're going to complete one about OSPF version 3, which is packet tracer 8.3.3.5. Now let's get started. Now I've already explained this to you guys. In packet tracer version 8, we have this very nice function called the dock function. If you don't know what the dock function is, it basically allows us to put the instructions right next to the topology in the same window, I would say. So it makes our life much easier in order to basically check the network topology and the steps that we need to take to configure the network all at once, so that we don't need to keep going back and forward between different windows. So just make sure you dock your instructions to the network topology, and let's get started. So the first information we have here in this table is the IP addressing scheme of all the networking devices that we have in the current network topology. So we do have three routers, router 1, router 2, and router 3. We also do have 3 switches and 3 host machines. Now, every single one of the routers, it's not something new to you that every router only knows about the networks that they are immediately connected to. So router 1, for instance, only knows about 3 networks. Router 2 only knows about 3 networks, the ones that are directly connected to it. And the same goes for router 3. Now, in order to make this network fully connected, we need to make sure that every single one of the routers, they know about every single one of the networks in our topology. So let's scroll down and see what the activity is telling us to do. So part 1 is telling us to configure OSPF version 2 routing. Step 1 is configure OSPF on all of the 3 routers. They should be in process ID number 10. And the router ID for each one of the routers should be all 1s, all 2s, and all 3s for respectively router 1, 2, and 3. The network address for each interface needs to be configured. The LAN interface needs to be set to passive, and we should not use the default keyword. So if you remember the default keyword, what does the default keyword does? Anyone?
It puts all the interfaces into passive mode.
Yes, exactly. So if we use the default keyword, all the interfaces will be passive. So it's telling us not to use it. All right, because after all, we have more interfaces that we want to advertise than interfaces that we don't. I usually just choose to use the default when I have more interfaces that I don't want to form adjacencies than interfaces that I want to form adjacencies. So whenever you have more LAN interfaces than serial interfaces, for example, I usually go with the default keyword because I'm going to have more interfaces that I don't want to advertise than interfaces that I want to form and send hello messages to. All right, the second step is to verify OSPF routing is working, is operational. And part number 2, verify configuration. So verify that all the devices, all the PCs can ping each other. Very simple, straightforward activity. It's going to teach us how to configure OSPF. So let's do just that. So the first step that I'm going to do, even before start doing part 1 and 2, is going to every single router and show the routing table to see what the router actually knows about. I'm going to click on router 1, CLI. And how do I check the routing table on the routers? I know we just came back from the break, so you guys may start forgetting things. So how can I check the routing table on the router?
So IP route.
I'm going to do show IP route because I'm in global configuration mode. And that's what we have. Just as we already mentioned, the router only knows about the networks that are directly connected to it. So we're going to be able to see the 172.16.1, the 192.168.10.4, and the 172.16.3, which is the other serial interface. Please note that router 1 has no idea how to get to PC2. Router 1 has no idea how to get to PC3. That's what we need to do. We need to teach router 1 how to get to PC2, and we need to teach router 1 how to get to PC3. The easiest way to do this, configure dynamic routing protocol so that we don't have to worry about configuring the routes manually. All right. So let's go ahead and do just that. So I'm going to configure all the routers with OSPF following the instructions. Now, if we show the IP route on router 2 and router 3, we're going to see a similar thing. The routes are going to be slightly different because they have slightly different networks connected directly to them. But it's going to be the same thing. They only know about the networks that are directly connected to them. All right, so let's go ahead and configure OSPF. Let's begin with router 1. I'm going to open router 1 CLI, and we're going to begin configuring OSPF. Now, once again, how do we configure a dynamic routing protocol? Does anybody remember? So if I'm inside the global configuration mode of a router, I can just type it in router.
Router, OSPF, and process ID.
Yep. So before we actually type OSPF, what are the options that we have in router command? We can configure BGP. So if you guys remember our lecture about dynamic routing protocols, BGP is used for different autonomous systems, usually between different internet service providers, different ISPs. We also have the interior gateway routing protocols, the IGPs, that include EIGRP, which we already configured previously, OSPF, and RIP. Okay, the simplest one to understand is RIP, because RIP makes decisions based only on the hop count. OSPF makes decisions based on the cost, which is associated to the bandwidth. And EIGRP that we already discussed makes decisions based on what? By default.
Bandwidth and delay.
Bandwidth and delay.
Specifically bandwidth and delay.
So the biggest difference here between EIGRP and OSPF is that OSPF doesn't care about the delay. EIGRP actually considers the delay as well when calculating the best path. All right, so our purpose today is configuring OSPF, so we're going to go router OSPF. We're going to use the question mark to see what we need to type it in. What is this? This is the process ID. You have to remember that in EIGRP, we need the autonomous system number. And in EIGRP, all the routers, they have to have the same autonomous system number, otherwise they will not become friends. With OSPF, the process ID is locally significant. It's locally significant, that means only the router knows about it. What has to be the same for the routers to form an adjacency in OSPF is the area number. Cool. So if they are in single area, they have to have all the same area number. All right, so let's go ahead and choose the process ID. It actually tells us to use 10. So we're going to go and use 10. Now, once we type this command, we're going to be enabling OSPF version 2 on our router. I'm going to go and hit enter. And that's all we need to do to enable OSPF in a router. All right, now that OSPF has been created with process ID number 10, it's a matter of setting up the router ID. Do you guys remember what happens if I do not configure the router ID manually? Anyone remember what happens?
It will use the highest loopback interface ID. And
Yes.
when it is not available, then it will use the highest IP address assigned to the available interface, active interface.
Perfect. So it's going to use, if I don't set it up manually, it's going to give itself the highest loopback address if there's a loopback. if there is no loopback, it's only going to grab one IPv4 address of the highest active interface. Okay, the highest IP of the active interface. All right, so we have to set it up manually here. So how do we set it up manually? Router ID, right? And then we type it in the router ID. The router ID, if you guys remember, it's in an IP address format. It is just to represent who the router is. It's not an actual IP address. Do not confuse. Do not get confused with this. It's not an actual IP. All right, so it's not routable. It's only to identify the router. So we've been asked to set it up as 1.1.1.1, and that's exactly what we're going to do. Router ID all once, and we are done. Our next step is to make sure we advertise the interfaces out of the OSPF process. And then we are going to set up the LAN interface as passive. Does anyone remember the steps to do that? How do I advertise the networks?
Using the network command and the IP address and what do we call that?
And what else? Wildcard mask?
Wildcard mask.
All right, so let's go and do that. Network. So which network you want to advertise first? Doesn't matter, right? I'm going to advertise the LAN first. Okay, so remember that this is not the subnet mask that we need to specify. We have to specify the wildcard mask. In this case, the wildcard mask is, what is it, guys? So remember the wildcard mask is
0.0.255.
Yeah. So remember the wildcard mask is the inverse of the subnet mask.
Subnet mask.
Okay. So if the subnet mask is 255.255.255.0, which is the case for /24, the wildcard mask is going to be 0.0.0.255, which is the inverse. Okay. One interesting thing here is that if you add the wildcard mask and the subnet mask, you should get the all 255s. Okay. All right. This is the first one we're going to advertise. Is that enough? Now, this is all we need. Or yeah, we need to specify the area. Yes. Okay. Now, every time we have OSPF single area, just one area, this area has to be 0. Now, if there's one thing about OSPF that you must know is that area 0 should always exist, because area 0 is known as the backbone area. So area 0 is the area that advertises networks to different areas. So all the other areas, they should have access to area 0. But we're going to discuss more about that when we get to multi-area OSPF. For now, you just need to know if we only have one area, this area has to be area 0, and that's it. And there you go, we just advertised the first network. Now, how do we advertise the other networks? Let's go ahead and advertise the 1630. What is the wildcard mask for this? /30? So whenever you need to know the wildcard mask, think about the subnet first. So the subnet for /30, which is a point-to-point network, is 255.255.255.2. Because the wildcard mask is the inverse, it's going to be .3, right? And this has to be area 0 as well. And that's all we need. And then we're going to advertise the last but not the least important network, which is the 192.168.10.4. Same thing goes here. It's a point-to-point, so it's 0.0.0.3. And it's also part of area 0 because this is single area OSPF. All right, we're pretty much done. Our next step is to make sure that the LAN interface is passive. How do I make sure an interface is passive when configuring OSPF version 2?
Using the command passive interface?
Yes. So passive interface, and then we specify the interface. In this case, which one is the LAN? I think this is gigabit 00, is it? Yeah, so it's gigabit 01. That's exactly what we're going to do. So passive interface, gig 01, or just G01. That's it, we're done. We have just configured the local area network interface as a passive interface. And do you guys remember what that means? It means that no hello packages will be sent to the local area network because after all, we don't even have any routers in the local area network. So we don't want to be sending hello packets here. All right, what's the next step? Let me just check the IP interfaces here because show IP interface brief. Because I don't think it's gig 01, is it? Yeah, so it's not gig 01, it's actually gig 00, the one that goes here. So gig 01 is actually the switch interface. Let's fix that. So I'm gonna go back to OSPF 10. I'm going to remove the passive that I did in gig 01 because I don't need that. And I'm going to put it into gig 00. All right. And now we're talking. Okay. So make sure before you actually finish configuring your router, you check the IP interface brief to make sure that you're setting up the correct passive interface. All right, done. Router 1 has been configured. Do we have any OSPF neighbors? We can check with the do show IP OSPF neighbors. Oops. And we'll see that we have no neighbors. We have no friends. We cannot talk to anyone yet because the other routers have not been configured yet. All right. So what I'm going to do right now, I'm going to give you guys 5 minutes so you can try to configure the other two routers and make sure you get the 100%. In 5 minutes, I'm going to do those two as well. And we're going to check the OSPF neighbors on each router. Okay. Now, if you're watching the video, the pre-recorded video, make sure you pause the recording right now and then try to do the other two routers. All right, so now we're ready to do the other two routers. Now let's move on and do the second router, router 2. CLI again. Enable conf-t for configure terminal. Now once again, OSPF router, OSPF process ID to be used is 10. Remember the process ID is locally significant. So it pretty much doesn't matter which number you want to give because it's only going to be locally significant. The router is not going to send to any other router. Now we're just configuring process ID to be 10 here because that's the one that is asked in the activity. So router OSPF 10 initiates the OSPF process. And now it's just a matter of assigning the router ID. Remember that if we don't assign the router ID, the router will try to assign itself a router ID based on the highest IP of the loopback interfaces. If there are no loopback interfaces, the router is going to try to assign the highest IP of the active interfaces. All right. So that's it. Let's assign the router ID. Now, please remember, guys, that if you start advertising the networks before the router ID, you have to clear the OSPF process with the command clear OSPF process. So that's why every time you have to assign a router ID, make sure you do it first. If you don't like to clear the OSPF process, you're going to have to reset the router, which is inconvenient. So make sure you assign the router ID before anything else. That's what we're going to do. And our next step is to advertise the networks in router 2. We're going to start with the LAN 172.16.2.0 and the wildcard mask followed by the area number. And we're going to do the other two networks as well. One more for us to go. And we are done with router 2. And we're going to see that a log message is going to pop up. This is a log message, right? It's basically generating an event. It's telling us, ooh, I became friends with another router, which is already configured with OSPF. Okay, so we see that there's OSPF adjacency change in the event code identification. And it says it's process ID. The neighbor is 1111. This is the router ID of the neighbor. So that means router 2 has already become friends with router 1 and they are now in loading done. That means they already exchanged the routes. And we can verify that because now we can show the IP route again.
I think for the 172.16.3.0, the wildcard, I think you made a mistake. It is a /70, but you put 255.
Oh, yes. Thank you very much, Far. I'm going to fix that right now. Thank you. So the second statement. All right. So router OSPF 10. How do we fix that? No network. And then we're going to type. So this is the one that I made a typo. So the 172.16.3.0. I'm going to remove it. And then I'm going to assign the proper network, which is, yeah. All right, so it's done. And now we have configured router 2 correctly. Good to go. Now, how about the passive interface? We still need to set up the passive interface on router 2. Now I'm going to show the IP interface brief to see which one is the LAN interface. And as we can clearly see here, the LAN interface is gig 00. That's the one we need to set up as passive. And we do that by typing in passive interface gig 00. We are done. Now we can move on to router 3. Move on to router 3. And CLI again. So the first step, initiate the router OSPF process. Router OSPF 10. Assigning the router ID. Advertising the networks. I'm going to start with the LAN. Again, it's area 0. And the other two networks. This is a /30, so it's going to be a 3. And the other one is going to be a, oops. So I still need to advertise one more, which is the 10. So 192.168.10.4, 3, and this is also area 0. All right, so we basically advertised all of them. We have a few more adjacencies coming up. So we became friends with the all2 router, which is the router 2. And we also became friends with the all1s router, which is router 1. Okay, now we just need to make the passive interface on which one is it. So we need to check first. Do show IP interface brief to make sure it's gig 00, and it is. Router OSPF 10 passive interface gig 00, and that will do the job. We are now at 100 out of 100, 100% completion. Now, before we actually consider that this activity is done, let's take a minute here to analyze everything that had happened. I'm going to go back to router 1, and the same thing that we did in the beginning to check the routes, we are going to do in router 1 again. So we're going to check the routing table in router 1 with a do show IP route. And you guys are going to tell me what happened here and what is different here in router 1 compared to what we did in the beginning.
The router had added routes long through OSPF, which is signified by O in the beginning. That is like 172.16.2.0. Via 3.2 and 192.168.1.0 via 10.6. And then we have another one 10.8 through 3.2.
Yeah, perfect. All right. So remember that the routes that we learn via OSPF, they are shown in the routing table with an O for OSPF. Does anyone remember what is the code for EIGRP?
D.
D. And does anyone know what this is? This is the administrative distance.
Administrative distance.
All right. So this is administrative distance for OSPF. Does anyone remember what's the administrative distance for EIGRP?
For internal, it's 90 and external 170.
Perfect. Okay. And that's all. Now, how can we check the neighbors, the OSPF neighbors?
Do so IP OSPF neighbors.
Check it out. We have one neighbor, which is the all 2 routers, another neighbor, which is the all 3 routers. It's actually telling us which interface they are communicating to. So serial 000, we have the all 2 routers, which is router 2. And the serial 001 is the all 3 router, which is router 3. And how about this? What is this? Full state.
Fully converged?
Yes, it has converged. They have already exchanged the information that they need. They have already communicated. They have already gossiped about the networks. Let's put it this way. Okay, so full means awesome. Okay, it's working beautifully. How about this?
No idea.
There was supposed to be something in front. Now, this is only like this because this is a point-to-point connection, a serial point-to-point connection. If this was something else, like a broadcast network or a non-broadcast multi-access frame relay or anything else, that would need an election. Do you guys remember the election? So there's actually no election here because it's just a point-to-point connection. One router goes directly to another router. So there's no election. There is no designated router. There is no backup designated router. You guys remember that? We discussed before the break. It's not here because it's a point-to-point connection. All right. So is there anything else? There is actually. What else can we see about OSPF? Show IP OSPF database. Let's check the database. Okay. The database will also show some interesting information for us. The process ID of the router that we are currently in, the area that the information is being advertised from and to, and the advertising router. So it's actually has the advertising router information as well. Okay. There's an age time for the LSAs because after a while, the LSAs, they get removed. Okay. So there's also a timer for that as well. And then they have to exchange information again. All right, cool. That's all we needed to do for the first activity. All right. So